How you going, guys? Kurtis from Cutting Edge Engineering. So today I'm going to be doing a upgrade to the jig borer that I've been meaning to do for the past 18 months. And as you all know, I love hands-on, everything manual, and because we have such a big variety of tooling for the jig borer, it means that no job is off limits. We can pretty much do anything we want. So I finally decided to put a little bit of time aside so I can start doing a few upgrades on the machine because I am using it more and more. What I'm going to be doing is replacing the hand wheel on the side of the bridge that moves the head from left to right, because it got broken off at some stage of its life. I don't know when. We didn't get the old one with the machine when we purchased it. I'm also going to be making an oil cap that fits on top of the gearbox so no debris can get in there. And there will be a few other bits and pieces I'll do while I'm working on it. So by doing all these upgrades, it's just going to make it that much more enjoyable to use it. Right, so the two hand wheels I've got my hands on, they aren't the correct wheel for the SIP jig borers. The SIP jig borer wheels are a 5-spoke and they are also a stepped hand wheel. They're not the standard dish style you would find on most other machines. So I am going to fit one of these, but if a real one ever come along, I would change it out so I could keep the machine original. This hand wheel, it is cast iron. It is 14 inches in diameter. I'm not 100% sure where I got that from. I might have acquired that through something I bought from an auction or an older machine, but I just can't place where I got that. And this hand wheel, it is also cast iron, but it is 15 inches in diameter, and I got that passed on to me through a family friend, but I can see that it has been repaired before. All of the spokes have been cracked and it has been welded up. So even though I would like to use the bigger hand wheel, unfortunately it is damaged and I don't want to put that on the machine. So to get started, I'm going to lower the bridge down so it's at a nice working height. Then I need to remove the end plate that retains the shaft that drives the lead screw. I haven't actually opened one of these up before, so I don't know what's inside, and it'll be interesting to see how things are done. Wait a minute. I really hope I don't have to take the whole lead screw. That might have all gone in as one piece, all the way through.
That moved.
It did move. Right, see these two threaded holes? So we're going to screw those bolts into those holes, and then we can use them to draw that out. So that oil comes out.
Ooh.
Whoa, just the bearing.
Standing.
It's not feeding at all. Now that I've got that off, I can see the plate I just removed is a thrust plate, and it is to hold pressure against the clutch in order for the feed to work in its different speeds. I'm not totally sure. So I can't see exactly what's going on. I have had a quick look through the manuals and the books that came with the jig borer. There's nothing in there that tells me what's behind this. I am going to remove the top so I can see what's inside. Aha, that's helpful. Put that back on. So that's actually a thread, but only to here. It stops there. So maybe it used to be a puller. There was a thread for a puller, but when the wheel got broken, it probably took that with it, but someone's tried to clean that up. see if we can draw it out. Nothing's moving. Because there's springs involved and it's under tension, I'm going to put on some glasses. Try and grab on the area where it would shoot up. Righto guys, so after doing a pretty extensive investigation on this end, I can't really see any way that these come apart. There is nothing obvious that's standing out to me. So I'm gonna go down the other end of the lead screw. I do have a suspicion that I'm gonna have to remove the block and take the lead screw out in one complete piece, because there doesn't seem to be any other way to remove the hand wheel components without completely removing the lead screw out of the machine. So let's see what we find next. What I'm thinking is we'll undo that cap, we'll then find the end of the lead screw. It'll probably have some sort of nut or a snap ring on it. And the shaft is probably assembled out of the machine and then fully installed. We'll find out. And that would be the lead screw, the end of the lead screw. So we'll undo that nut there. Once we undo that nut, the lead screw will then be free of the carriage, and then we should be able to extract the whole lot, hopefully. Bolt. Thrust block.
Wow.
So strong though, they stick to everything. Oh. How are you supposed to get to that?
Oh.
No. Oh, I've got to take that off. Okay, there's the nut. Once we remove that end, we should be able to unwind it out. We will leave that in place. We will undo that nut that holds the rod in the block, and we should be able to then unscrew it and it all go that way. This is where these machines come into their own. A lot of other styles of machines would have a thrust retaining area at the point of where it's driven, and this end usually just floats around in the breeze, or it just sits in a sleeve. They're not actually retained at both ends. Now I need to come up with a very, very crazy little spanner. Where's a washer? It's a washer with a flat on it. It fits in the socket. So I put in that, and hopefully we'll just undo it. Fingers crossed. Doesn't fall out on me. Let's turn on the lead screw. What are you doing, George? Just needed a bit of help. That shaft is now free of the block and free of the head. Need to relock it. That's locked. Now we should be able to just wind that out. So I'm getting a bit of resistance when I'm trying to remove the lead screw. What I can see, the other end of the shaft has a bearing on it to support it, and it is actually moving in and out of the housing, which means it is binding on the shaft. So what I think we're going to need to do is just slowly work it out using a bit of inertia and momentum, and slowly draw it out of the bearing without damaging anything.
There we go. Whoa. Oh my god.
Why is that freely moving now? That didn't freely move before. So after I actually got the lead screw to start to move, all the pressure came off the clutch, and I was actually able to pull that off without any issues at all. While it was in there and installed, I couldn't actually move it. I wasn't going to try and pull on this too hard in case I did break something. Why couldn't we get that off while it was in there? We've taken the spring retention off it. That's why. It still doesn't make a difference because we still need to get that off so we can then make up whatever's going to go on here for the new hand wheel. It's got to come off this way because it's going up against the shoulder. Now what we're going to do, we're going to have to machine that until something happens. Something is restraining this from coming off because you've got springs there, and when you wind that, it forces the springs and closes them. There's got to be something retaining this to the shaft. You can usually find things, but this is just next level. Keep getting it out.
Wow.
We got the lead screw out, but there's still no obvious sign to how the sleeve that the hand wheel would have been attached to is actually fitted on the shaft. So we're going to put it on the bench and see if we can figure out why. Australia icon.
Gentle, gentle. Go on, go get it.
Righto, so we got the lead screw out. So even though we've got it out on the bench, there are no obvious signs to how this comes apart. You can see that this shaft here is a larger diameter than the shaft in here. These 4 springs then apply pressure to the friction drum, and that is controlled via the part of the handle that is actually broken. It is what actuates this friction drum in and out. So there is something retaining that onto the shaft, and there is a ramp and a pin or a ball underneath the sleeve that does the movement there in order to compress those springs. Because the diameters of the shaft get from large to small back to large again, that tells me this has to come off somehow. But when it was in the machine, we couldn't get the other half of the friction plate off, so we weren't able to see what was behind it. Removing it and doing it on the bench is definitely the best method. We're just gonna have to keep having a look at this, try and compress these springs without using that sleeve, and hopefully whatever's retaining it might expose itself. There's tension there. But we need to be able to compress that and see if a detent ball or something falls out from somewhere. Failing that, because the diameters are different all the way through, that probably unscrews or it is pressed into the end of the shaft. But because that sleeve is already damaged, I'm inclined to throw that in the lathe and slowly machine this back until we find something. Whatever was here, and I don't know what this actually looked like, so it's really hard to gauge how it all went together. I don't think we're going to be able to get that off without doing that.
Oh.
So because there's a thrust bearing in there, that means this end must come off. But because there's actually no physical way to grip onto that to get enough twist on it, what we're going to have to do is put this in the lathe and machine this sleeve back a little bit so we can then expose that shoulder. Once we've got that shoulder exposed, we might be able to grab onto it with something and undo it. Uh-oh. But that is extra terrifying now because the plate is under full tension of those springs, because something fell out of place when I pushed on the sleeve. Everything is now under tension, so if it releases itself, it's going to scare the out of me. Righto, so I've machined that sleeve back a little bit, trying to expose that shoulder. That is actually not a shoulder, that is a washer that spins independently of everything on the shaft. So after working that out, I then realized that there is actually a shoulder that that washer is pushing up against. So I figured the end of the shaft must be a bolt or a fastener of some nature. I then tried to use some multi-grips to undo that, and all it did was chew up the shaft. So because we're back at square one, we don't know how this comes apart or goes together. So I'm gonna go back to the paperwork and the books and have a more thorough look to see if there is any indication as to how this comes apart. Righto, so after going back through the book, I have found that exact shaft I was looking for. It's not entirely detailed, but it does sort of show you a mud map on how it should be assembled. So what I've worked out via the drawing, there is a circlip missing. It shows it clearly in the illustration that it should be there, but the problem we have is our shaft doesn't have one on it. So what I'm thinking, the guys who had the machine before me did a modification to the shaft after the hand wheel broke off so they could continue using it. But it doesn't make sense why they didn't repair the hand wheel while they had everything apart, because that circlip is what retains all of this. So now that we've worked all that out, we have two options. I can either assemble the machine back to the way it was and forget about replacing the hand wheel, or I can continue to pull this apart and try and fix it properly. So of course we are going to continue on. So what I'm going to do, I'm going to machine this little shoulder off in front of this thrust washer. That will hopefully then allow everything to be pulled off the end of the shaft. But because the friction drum is under spring tension, I need to restrain that back to the chuck. So when I do machine off that shoulder, nothing flies off and goes missing. So we're going to do that. That little wash is free. Everything else should be free. So now we'll take the tailstock out of the way. We'll put the face of that tool up against that with a copper pad in between it. We can release that. Lock the carriage. So there's a little washer that was retaining everything. We also have the end of the thrust bearing, well, the bottom plate. So we also have the thrust bearing, which was doing all of the turning work. So this part here is a sleeve which originally would have been the hub of the hand wheel, so there would have been a flange out here somewhere for the hand wheel to be fixed to. Inside of that we have a twin ramp. So we also have 4 balls. 2 of them go on the ramp that came out of this sleeve, and the other 2 go against the friction drum. They are basically a shock absorber. So as you go to rotate the hand wheel, rather than break your wrist, it has a bit of spring retention and then it allows it to turn. So that's that one's corresponding ramp. Those 2 were opposed like that. And then as they get turned and the balls are in those grooves, it expands it. Mechanical advantage, a longer ramp to a short ramp. So because it's longer, you get a mechanical advantage. It's very easy to push a load up a shallow hill than it is to push it up a steep hill. So because you've got a long ramp and it's much shallower than that ramp, this allows you to create mechanical advantage. So when you are turning the hand wheel, it will automatically engage. It's no like heaving on it. So there's nothing needs to be done in here, it's all the end. That used to be the circlip groove. I still think there's something happened to the end of this shaft. So that doesn't look genuine. It's got very sharp edges to it. See, there's no way to remove that without removing that shoulder. Something has to be, there has to be something threaded, or they've welded it up and machined it back, but there's no telltale signs of weld, which would be discoloration of the material, like it turning blue or straw. That must be threaded into the shaft, because there's no way that you would get all of that assembled. That still doesn't go any further than that. So it doesn't go past that shoulder. It has to be that. It has to be. So now we've successfully got all of that apart. I am going to take the friction drum off the shaft and the spring so I don't lose anything. I also need to do work to the end of the shaft once I work out how I'm going to make all this work again. I'd rather than be out and in a tray and go put all this over there out of the way.
Whoa.
I'm going to go put all this away safely. So now we've got that safely apart, I can have a really good close look at all the details that are on the shaft. I can see that the shaft is 100% original up to the very end where the circlip would have been. The circlip groove is still there, but something has been made and installed in the end of the shaft to retain everything that then gets fitted onto it. What I believe they have done is they have machined up a bolt and they've installed that using either Loctite or something like that, because it is extremely tight. I can't get it undone, but the drawing does show there is an original thread down the end of the shaft. It doesn't designate what thread it is. I'm not 100% sure what it is supposed to be, but what we have in the end is an M8 thread. So what I'm going to do next is I am going to heat up the end of the shaft. Hopefully, if this is a fastener they've put in there, it will change color before the rest of the shaft and it will actually expose the join between the two. That will also help melt the Loctite if there's any in there. Either way, I'm going to have to modify the end of the shaft, so hopefully by heating it up I'll be able to undo that. If I can't, I'll have to come up with another plan. So what I'm going to do, I'm going to put an M8 bolt in the end of the shaft with a locking nut. I'm going to get that tightened up so when I do apply a little bit of heat, if I can smell Loctite burning or I can see something going on, everything's set up, I can quickly grab a spanner and hopefully undo it.
Oh, that was the nut moving. Yeah.
No idea. Nothing. There's no way that washer could have been put on there and then a shoulder put on in front of it, part of the material.
No.
Righto guys, so I am admitting defeat on this for now. Unfortunately, I've run out of time on this. I figured this would be a couple of hour job to change out a hand wheel and do a few other bits and pieces. but this has blown out significantly. So I am going to put this aside for the time being, and I will come back to this at a later date. But because we've gone this far, I'm not going to go and fit that generic style hand wheel onto the machine. I would like to make an era correct hand wheel that is as close to the genuine one as possible. So I'm going to have to draw that up and order in the material. So even though today didn't go exactly to plan, I am looking forward to the end result, which will be a lot better than I first planned. But it has been a massive eye-opener to see how things were done. That there is just premium Swiss engineering. I have learnt so much more about that machine and how things were done back in the day. So that's it for now. Stay tuned for the next video when we continue on our jig borer. Thanks for watching. So to get started, I'm going to lower the bridge down so it is at a more... so I can then remove... I would love to get my hand... Oh wait, that sounds fucked.
Yeah.
So to get started, I'm going to lower the bridge down so it's at a nice work... I'll just put my fucking tongue. Bang!
Oh, you're so lame.
Hopefully it's not a special style of Acme nut. And there aren't a shit ton of balls and rollers that fall
Oh my
out
god.
everywhere.
Oh my god, it's making me feel sick.
But, hold my beer.
Famous last words. Carl, you need to leave. Stop influencing this show.
Oh, you can't see shit. For fuck's sake.
Oh my god.
There's no way that washer could have been put on there.
Magic.
No, not magic. So it looks like they've made a modification to keep the machine working. I've sort of made a fucking mess of that, but I'll fix it. I know a guy.
You know a guy, thank
Right.
God.
So even though today didn't go to plan, I am looking positively towards the future. Oh, fuck. Help. Hey?
My jig borer is
I'll
broken.
fix your jig borer. Unless you know how to pull jig borers apart, fuck off.
He's still here. What? Magnets? The one on the fridge? Karen saves the day again.
I can't see there's going to be any other way to remove the hand,
Jesus Christ.
so I don't think there's going to... Right, because I can't see there's going to be any other way to remove the hand wheel. Fuck off, birds. Seriously, I'll
Don't
throw
throw-
something. One for you?
Wait, did you just eat one of them?
No.
You said one for you, and then I thought you put one in your mouth.
One for you? Yeah.
Who's that?